All right, so this is our first lesson in JavaScript. So I hope that's going to work out okay for you guys. I don't know, have you done any JavaScript? I mean, it's our first lesson in JavaScript, but have you done any in anything else? Have you seen it before? All right, so you're going to be telling me. That's good. So what we're going to look at is, got some things here. So I hope you know about the script and the non-script tags. We just use the non-script. Is there a better way of using this? Mouse is very hard to work with. Sorry. Trying to figure out a better way. If I do there, oh, maybe I can even do that. Yeah, it's just kind of fidgety. So yeah, you will do all of your script inside script tags. The script tags don't have to be in the head, but they can be in the head. The non-script tags will be used because if you think that your web page might be loaded onto some browser that doesn't support JavaScript, then you'd put a no script tags with just some information in there to the fact that it does use JavaScript. We have an alert, which is going to put a little box up in a corner for you. And just with some message, we got a prompt, which also puts a little box up, but the prompt will actually, you can use that to input data into your JavaScript. You've got some tools that you can use, your developers tools. So if you hit your F12, you could get your console log, which will sort of tell you a little bit about what you're doing. So this is just a little bit of background. The idea being that we do have this concept of the dynamic web. I probably am just wasting my time telling you about it because it's something that you live with, right? I mean, it's not something that is new to you. When the internet started, it wasn't like it is now. Like it is now is dynamic. Like it used to be was you would go and visit a web page and they would send you some data and that was it. It's kind of boring. But now we actually interact with web pages, and so therefore they are dynamic. And JavaScript makes that possible. It's one of the things that makes it possible. We're going to go through this quite quickly, I think. To consider how that works, it's good to have an idea of these two terms, our back-end programming and front-end programming. So back-end, we're referring to the server side. There's some things that we need to do the programming, the processing on the server. PHP would be that, all right? So if you're going to be doing your PHP, or even if you're writing in Python or Java, that's going to be on the server. If you want to, well, I've got a slide that in a minute, which shows why that's not such a great idea to do all your sort of processing there on the server because of the transfer of data between your client and your server. Client-side programming, on the other hand, we're going to do some of that processing on the client. So if we can reduce the amount of traffic between the client and the server, that's going to be a good thing in terms of our efficiency of our programs. So PHP is required, and I did mention Java and Python as well, but is required if we're going to be sort of working with databases on a server somewhere. PHP will do that quite nicely for us. But if we want to work with forms, and you've worked with forms, right? And then you might have an action in the form, which then activates some PHP on another site. You could be sending over a lot of really bad data, which, could really mess up the efficiency. If you're sending bad data over with your form, then you're going to have to reprocess it maybe multiple times. So one thing that was early considered was, hey, you know what? We could get an efficiency if we check the stuff before it went over. Check it before it goes over so that we don't have too much traffic going to and from. So this is showing what's going on with server-side processing. So we make a request to the server sends us back a form. We fill out the form, we send the form, then we get some kind of response. There's a lot of traffic going on. Well, maybe we could end up in a, if we have an error situation, we could end up almost in a loop here, right? Sending stuff there and back. So maybe we can cut some of that problem out by doing a little bit of error trapping on the client side. So client side programming, that's JavaScript. Now, JavaScript originally, that was what it was intended to do, right? The idea is, just as I've tried to explain it in the last minute or so, is to actually save you sending over bad data in your forms, to do some form pre-processing, to check the form before you send it, to make sure that the data is correct. JavaScript will do that. But computing people being computing people had a look at JavaScript and they decided, well, it could do a lot of other stuff as well. We could actually use it for some other useful things. And so that's how JavaScript is at the moment. So our client-side processing, as you see, if we have pre-processed the form's been pre-processed, we don't have to send it there and back, right? We've just got the form on our client and we can send it over. We've actually reduced the amount of processing quite a bit. Yes, reduce the processing, but also reduce the traffic over our network. All right, so what is JavaScript? As it says there, we use it for a lot of things. All of these major sort of corporations are using it in their products: Google Maps, Facebook, Microsoft Web Apps. Basically, any of the very dynamic, as we said earlier on, dynamic web pages where we're interacting with the customer in sort of real time, and with the customer, with the user in real time over that on that website. That disable thing there, that is kind of important. The no script tag that you can put no script tags after your script tags, because if people have disabled JavaScript, then all of your JavaScript won't work on their browser. And so you can use no script tags to indicate that, hey, I'm using JavaScript, but you're not seeing it, that type of thing, because they can disable it. Well, why would they want to disable it? Because JavaScript is a programming language. So therefore, you might be able to introduce some malicious code onto somebody's site, maybe with your interaction with them. So some people won't allow it for those reasons. And here's with JavaScript, you don't have to have the JavaScript in between the script tags. You can do that. So we got some script tags there, and we got our JavaScript written inside the script tags, just how you sort of expect with how we've seen with some other things, like how we do our styling, really, isn't it? But also like how we do our styling in that way is you can have another file with a .js extension, and you can put your JavaScript in that. It is interpreted rather than compiled. So, I hope you know the how that's going to affect it. Being interpreted means that is everything okay, Najla? Because it's being interpreted, it means that we don't compile the entire program at once and run it machine code way. I mean, it's one line at a time. And so that's kind of familiar to us, I hope. But it's kind of important that that works that way, so that it works with the actual changes that it makes to the web page as it goes. Because you can actually change the web page with your JavaScript. You can use it to access. Have you guys heard of the DOM, D-O-M, which we use to access different elements throughout the web page? So you can use your JavaScript to actually pinpoint into a particular point on the DOM and make changes to the different elements there. And that's what you're going to see happen when you do your lab. Your lab will have you sort of writing some JavaScript to make some little changes to a little website that you'll make. That's in this lab this week. Okay. So the next couple of slides are about the fact that, as I said, it runs in interpreter mode, so it's not just all sort of the whole thing crashed together in a in a bunch of machine code to run. It's affected one line at a time. But what we do have is we can load the entire page of HTML and then load our JavaScript, or we can load our JavaScript with the HTML. And that's managed with these attributes that we have with the script here. So you can say defer. If you use the defer attribute in your script tag, then what will happen is the JavaScript won't be loaded until after you've loaded the web page, which is attached to. If you use the async, then it will work it together. With async, the web page and the JavaScript will be loaded and work together. And so that's actually shown in this diagram here. I hope that you can see that. It's kind of small. Maybe you can see it. All right, so here we've got our script working just in its default way. And what's happened is that our JavaScript is just sort of running as it loads the web page. So some of the web page loaded before, some of the web page loaded afterwards. Here we've got async, and actually we see that some of the JavaScript is being loaded at the same time as some of the web page, and then afterwards being processed, then some of it there. If we use the defer, so here these are the attributes for the script tag. This script tag is just running its default mode. This one here with the defer attribute, and none of the JavaScript is either loaded or processed until the entire web page is loaded. It'll be the what? It's the same JavaScript, but it's just that the entire web page will be loaded first. Yes, it's about the loading and the processing. So yeah, so here the blue stuff is the JavaScript and the pink stuff is the HTML. And so what that's trying to show you is, okay, so if we just run the default, we can have our JavaScript start running before we've loaded the entire web page. If we run the async, yeah, some of our JavaScript will be loaded, or maybe before we finish, and it'll actually be processing at the same time as the web page. But if we use the defer, the entire web page will be loaded. And so maybe this one is a little bit more controllable. You know what's going to be happening before your JavaScript runs. So a lot of people will like that defer, so that they know that people are going to see the entire web page before they start getting JavaScript prompts. The no script I've already talked about. Perhaps I should have waited for the slide, but there it is. No script tags. They're really because of some people not having a browser, apparently, that will work with JavaScript. And so you give them a little message to let them know that you have JavaScript. I hope the comments look familiar to you. So, I mean, you've seen all kinds of comments, right? It's not the same as the HTML comments, but it does look a little bit like your styling comments, right? Or your CSS comments. You'd also find those comments would be the same in like Python. Oh, not Python, sorry, Java. All right. Mentioned a minute ago. Now, I don't know if this will work on this because this is a Apple machine and everything's different on Apple, right? But if you have your Windows machine and you press your F12 key, then you'll get your developer tools. But then you need to actually navigate, make sure that you get the right panel there. If you choose the console, you'll be able to sort of have a look at the tools there. Have a look at the script. Okay, so it is a programming language, so we can use variables, and we can define them by their type, or we can just use this let. Notice that what have we been using? Haven't been using Python. I don't know what programming you've done. Have you've been doing Python? Yeah, so Python doesn't need anything at the end of the line, does it? So we do. If you're going to use JavaScript, so it's kind of like Java in that way. It also has a curly braces, kind of like Java. So that may be something to look at, I suppose. So you can have these data types. I'm sure you're familiar with data types like this before. Numeric, basically any number. Look there, it includes the floats. Strings, Boolean, true, false, and object, which could be a complex data, which it could include a method. All right. Use quotes for your strings. You can use either of those quotes. So what do we got going over here? We've created two variables using two different ways of doing it. Let and var, still going to create variable, right? They're going to be strings because we have actually given a value to them, which is a string. We're using double quotes and single quotes. And this is showing concatenation. So use that word there. Yeah, there's concatenation. I'm sure you're familiar with concatenation somewhere, right? You guys done Python? So you concatenated strings in Python. Did you do Java at all? No. Well, you concatenated strings in Python, so that should look familiar to you. You can add them together and they put some space between them there. Now, what if you have a, oh, here we have some numbers in there. This is going to be a problem, isn't it? Sum equal lab grade plus test grade, because test grade is a string and lab grade is a number. That's why we need these special functions here. I don't know if you've seen anything like this before. The parse int, parse float. What that will do is if you've got a string like this string here, see, this is not a number, this is a string, double quotes, 50 double quotes. But you could take that and you could run it through the parse int function, and what would be returned would be the integer 50. And so you will be using that, no doubt, especially the place where you always have to use it. So this parse int, okay, where you've used Python, right? So in Python, you use the input command, input, right? And then you would put the input, enclose it in an int function, right? Yeah, to convert the text that the person typed in at the screen to a number. Well, that's what the parse int works the same as the int in that way. All right, so that just imagine that the parse isn't in front of it. It works the same as the int function that you used in Python. These other ones work like that too, parse float and number. Alert function, that's going to, okay, so it's like an alert, because what it's going to do is it's going to push a window up on the screen for the user. They're going to see the window, and the alert side, you're going to have a text string if you want. Yeah, you're going to put a little text string in there, and then they'll have to click a button that says okay, that they've read it. So that's all that's going to do. You can use console.log for yourself to sort of help you to debug it in that way. The prompt function, as I said, so I'm referring back to Python because you guys told me that you guys have done Python programming. So the prompt function is like the input function in Python, right? So you say, you set a variable equal to the output from an input command. So you do the same here with the prompt. Prompt works like input, because in the input, remember, we'd put some text in there to prompt the user. You'll have a window. Yes, correct. So yeah, the way that the user will see it will be different than how it works in, but what I mean is the way that you would use it in your code would be similar. So that's how this is being shown here. The result will be a string. If you wanted to take that, so this is what I was talking about in the previous slide. You wanted to get the age of somebody. You could write some code like this. Let will create the variable age. Then prompt is going to put up a little window, little box with and ask them to enter their date. Their date. They'll enter it, but it will be treated by by JavaScript as if it was a string. So that'll have to be converted, right? That's where you'd use your parse int. It would work okay with this one because it's just going to be printing out a string, reads in a string, prints out a string, no big deal. But if you wanted to do some mathematics with it, you would have to do that. Okay. This may be a little bit different than what you did in Python, because you said you haven't done any Java at all. So JavaScript. So basically, the way Java and JavaScript are working is we do need to use our braces for our control structures. So we've got braces there, whereas in Python, all you had to do was do your indenting. And notice also that we are using round braces for the conditions of our control functions. So we got a while statement, which kind of looks like the ones that we had in Python probably. While some variable is less than 5, then the brace there means we have to find the matching brace. So everything between that brace and this brace is going to be implemented. Oh, here it is. That brace and this brace is going to be implemented in the while loop. It's going to happen five times, I guess. Well, I starts out being 1 and I gets incremented. Yeah, here it is. At the end of the while loop, I gets incremented. So it's only going to happen 4 times, I guess. And then what we're doing is we're doing some kind of modular division. So we're getting all of the even numbers. And then this is the same, yeah, same thing, but oh, it's a for loop. It's not the same. It's a for loop. So in the for loop, notice, be careful you use your syntax right. That's semicolons. It's not commas. And what else there to look for, I suppose? Okay, you know about the incrementing with the I++. So basically, the for loop is just a neater version of what's happening in the while loop, isn't it? With less lines of code. We've taken the I++ and we put it into the same place where the condition was. And yeah. And also we've taken the initial value and put it into the for condition as well. So it's kind of looks, you could easily convert between while and for. Okay, so have you guys used arrays? Oh, okay. So here we said let ages equal. We created this array because we haven't used any quotes on it. This will be numbers. So an array must have a type of data in it. Array holds a type of data. So this holds a type of data, which at the moment is integers. Here's another way of creating a new array. Names equal new array. There's a much easier way of doing it, which would just be to say, let names equal, and just put up 2 square brackets. That'll create a new array with a lot less words. And then once you've got your array created, you can add values to it, where this is the index. The thing inside the square braces is the index. And so this must be an array of strings because it's assigning these names to those index places. And then this alert, what this would do is would be print Khalid in a box on screen. I'm sure that you remember that indexing starts from 0. Yeah, all right. So you've seen arrays before. You'd be aware that an array is sort of treated like an object. So you've got you can test different values on it. So names.length, that'll give you the length of the object, the array, how many positions there are in the array. That's useful if you want to do this thing that we call traversing. Traversing means to go from the start to the end of something. So here we can say we know what the length of the array is because we've got a application to do that, our length, and we have a value that, so this is going to loop through that and just the value of each of the things in the array as it goes. Doing the same thing, but using the for loop instead of a while. Bit neater. Again, it's using names.length. All right. So this is going to end when? As soon as it gets to the end of the array, because it starts at the first position. As long as we haven't gone past the last position, we'll increment each index of the array. All right, so a minute ago, we were talking about the defer business. You know, why would we want to use defer? We might want to, in our JavaScript, we might want to change things on the screen. And if you want to do that, you'd probably want to know what things are going to be like before you started changing them, right? So you might want to load the entire page first. And so that might be useful for you to use the defer for that. Now we have this thing here. Some people say that this is sort of ancient and sort of we have a more modern ways of doing this. But what we do have is you can do a document write, and you can, wherever was the last point that we were on the page after the JavaScript, you can just write some new HTML, which will just be inserted in there. So when I say write HTML, you put inside here some double quotes, and you can just write some text, or you could write some tags with some text. You could build all kinds of things inside the write statement. That's one way of doing it. Another way of doing it is you can use the document, yes, and you can go use the DOM, and you can go to a particular element in your web page, so you have a lot more how you say specificity, a lot more precision with that using the DOM. And then you can just sort of append childs, so you can have an element and append childs to it. That's not mentioned in the notes, I'm sorry, but I just thought I'd mention it to you that though this is given to us in the notes as a way of changing things on the page, there are other ways of doing it. So what do we got here? Yes, so this is giving an example of how that might work. Now, bearing in mind that this is code that would probably be written in the head. All right, but whatever has been rendered on the page, at that point, you would have this written there. Okay, would come up. So we've got an H1 tag with some writing, and then a paragraph tag with some writing. As I said, there are other ways of doing that with a little bit more precision, but that's one way of doing it. Now, I mentioned that to you also because in your lab that you'll do later this week, I won't ask you to do it now because then you'll have nothing to do on Tuesday, as far as I know. So I'll let you work now on your project. But in your lab, you will have to do some working with, sorry, you have to make some things happen on a page using JavaScript. So we'll talk a little bit more about that when we do the lab. All right, so let's stop that now. And I might just end it. Yes.